This video provides an overview of the proof of concept 1 of use case 1 of 6G-BRICKS project revolving around holographic telepresence in interactive broadcast. Let's start by having a look at a simplified deployment architecture of this proof of concept, and first let's identify the three main metaverse technologies that are integrated in this proof of concept. The first one is a real-time multi-user holographic communication platform by i2CAT. The second one is a virtual production engine by Brainstorm company. And the third one is a remote rendering technology by Exacom company that allows providing rendered video streams with low latency to remote audiences that are using lightweight devices. And then we include one 6G technology, which is a cell-free network that we are introducing in a little bit. Okay, let's continue by presenting the QLowen testbed in which these technologies have been deployed to be able to demonstrate and to evaluate the proof of concept 1.
Hello, welcome to the QLowen lab.
Thank you.
Here we have deployed all the use case 1 components in our 6G-BRICKS testbed. This testbed is a key enabler as it integrates a whole 6G radio infrastructure, and we are using a cell-free ORAN architecture. The radio units are deployed in this USRP export 10 from National Instruments together with a dedicated mini PC, and they run the low physical layer, and then the central unit and the distributed unit is implemented in this server, dedicated server, which does all the rest of the processing.
Okay, let's have a closer look at the main 6G technologies included in this rack. First, we can identify the cell-free radio unit. Second, we can identify the X-Hall infrastructure. And basically, X-Hall networks have become a consolidated transport infrastructure in modern cellular networks that connect the radio access network to the core network. And they include three main segments. These are the front haul, the mid haul, and the back haul. In particular, the wireless X-Hall network provided by Intracom in 6G-BRICKS project follows an open architecture including both outdoor millimeter wave radios and disaggregated routers. Interestingly, this infrastructure is able to support in-network computing capabilities which have been leveraged in 6G projects to deploy metaverse communication services, thus allowing us for self-contained services without requiring additional or extra edge or cloud servers. And finally, we can identify the central unit distributed unit. Okay, let's now introduce the cell-free infrastructure provided by IS Wireless in use case 1.
Hello, I'm Robert, I'm from IS Wireless, and our solution of cell-free, which was developed for 6G-BRICKS project, provides benefits in throughput and spectral efficiency performance and extending the cell. It is highly visible when the user is served by a single RU and the UE is near to the edge of the cell coverage. Multi-RU allow us to extend the cell range, perform better throughput results and spectrum efficiency. Moreover, the multi-RU allows to extend the coverage without any additional DU.
Okay, let's continue by watching the final result of the proof of concept 1 when deployed at the QLowen testbed. This is the final result of the proof of concept 1 of use case 1 of 6G-BRICKS, and here you can see the final program, the produced program ready to be distributed via broadcast. And here we have Janice from i2CAT. Hello Janice, interacting with a 3D model of the car. Hello. Didier acting as the presenter. Hello Didier.
Hello.
And we have on the side Raquel from QLowen also as a VIP panelist. Okay, so what's the deployment behind? So we have one radio unit from IR Wireless of the cell-free network, and at the top of the room we have the other one, okay? And what is the deployment behind? So we have Janice using the headset. So Janice is like inside the VR program. Janice is interacting with the 3D models via the VR controllers, and is captured real time with an RGBD camera, okay? Same setup for Raquel, but Raquel in this case is not wearing a headset. That's why in the Produce program you don't see Raquel with a headset. And let me show you the metrics that we are getting from the XR service components, okay? So in this case are the send and the receive bandwidth, send and receive FPS, and the latency. And if we move to Pablo, we can see that Pablo from Brainstorm is moving a tablet with tracking, and the movements of Pablo are being reflected on the final TV program, okay? So he's acting like a realizer. And finally, we have the software from Hexacon, which is receiving a streaming to lightweight audiences, okay? So this is managed by Germain. Hello, Germain. And we have Robert from Meyer Wireless managing the 6G cell-free network, and we can see the second RU here, okay? And we can see that the laptop is also connected via smartphone to the cell-free network. So in essence, that's an overview of the deployment of the PoC 1 of use case 1 of 6G-BRICKS. Okay, let's watch now a short sequence of the point of view of the VR user. He has a menu, he can interact with the presenter, and he has a menu to select different parts of the Formula 1 car and to show them interactively to the audience. Mm-hmm. Okay, we are assessing this proof of concept 1 of use case 1 of 6G-BRICKS by considering a diverse set of key performance indicators from both metaverse enablers and the 6G enablers. From the metaverse enablers, we can highlight a set of metrics. These include the throughput, the transmission and the end-to-end delays, the frames per second, and the packet loss. And from the 6G enablers, mostly from the cell-free network, we are considering the throughput, the spectral efficiency, the extended coverage that we leverage by deploying a multi-RU setup compared to a single RU setup, and the packet loss. Finally, we also want to assess the benefits and the potential impact of this technology in our society, and we are doing so via a set of key value indicators. In this particular proof of concept, we have selected 3 of them. The first one is the digital inclusion or fairness, to determine to what extent this technology can facilitate or guarantee equal access to key services. The second one is the trustworthiness, because this technology allows to interact with real-time captured holograms in the metaverse and not with impersonal or inexpressive avatars. And the third one is the energy efficiency, because this technology allows remote virtual activities and services, thereby minimizing the need for physical resources and travels. So that's basically an overview of the proof of concept 1 of use case 1 in 6G-BRICKS. Here we list the list of involved partners and their roles, and we also hope this video can help us to gather valuable feedback from both end users and professional users or stakeholders to also assess the potential impact and benefits of this technology in our society. Thank you.